All right, so here is 2.1, beginning of our module 2. We're doing integer exponents. And today we are going to mainly be just kind of discovering and working on all these power rules. Okay, so the first one is product of powers. So this is where if we have the same base, we have to add the exponents and keep the base. So remember, we discovered this. Excuse me.
Chloe Locker, please meet your mom by the bike cage. Chloe Locker, please meet your mom by the bike cage. Thank you.
Didn't have time to pause. So this is where we did this in class. Remember, we learned that we can add the exponents and keep the base. So the next one is called quotient of powers. So quotient, remember, needs to divide, right? And so we have the same bases. We can subtract the exponents and keep the base. So remember, product means to multiply, quotient means to divide. So these two we did in class today, so that's kind of neat, right? All right. Next one is power of powers. That's where we multiply the exponents and keep the base. So remember, that was when we had something like this. Okay, a power raised to another power. All right, we have product of powers. We apply the exponent to all the bases in the parentheses. Okay, so this was new, product of powers. So that's when we have like two things inside the parentheses. We have to apply it to everything inside the parentheses. See, product meaning multiplication and power. So it's product of powers. All right, of a power. I'll put an example here too. And then I'll put one here too, just so that we can have some reminders and some refreshers. All right, and then I'll do this one too. All right, so make sure you copy those down. I know this is a lot to write, so if I talk faster than you can write, right? Remember, you pause and make sure all of this gets put in there. So this is probably going to be the longest part of your video, is pausing and making sure all this gets in here. So negative power is the trickiest one. We take the reciprocal. Remember, reciprocals where we take our fraction and flip it over of the base and apply the exponent to the base. So if I have x to the negative 3, the negative tells me to take the reciprocal. So that's where I'm going to flip it over. And then it just says apply it to my base. My base was x, so we're just going to stick it right back on that x like this. And I'll explain this more in our examples. All right, and then zero exponent is that the result is always 1 unless the base is 0. I thought I added in my s earlier, so I'm going to add that in really quick. There we go. Unless the base is 0. So anytime you have anything raised to the 0 power, it's always going to be 1, okay, unless it's 0. So if we have x to the 0, it's going to be 1. All right, so we're going to practice these now, and we have lots of examples. So here we go. We've got this is our product of powers, right? 5 to the second, same base, and we get to just add them, right? So we're going to go 5 to the second plus 5, and we're going to get 5 to the 7th. So we don't have to actually find what 5 to the 7th is, okay? All right, so then the next one, remember this is quotient of powers. We subtract, so we're going to go 6 to the 8, take away 3, and that's going to get 6 to the 5th. That was actually one of our examples on that worksheet we did in class. All right, we practiced this one as well. So this is our power to a power, right? So we go 7 to the second times 4, and we get 7 to the 8th. We just multiply them. All right, here's where our new ones come in. This is a negative exponent. So the reason we can take the reciprocal is, remember, everything can be put over 1. So the negative is where we reciprocal. All right? So we go like this. Oops. We flip it over. And then I just apply the 6, and I take that exponent and put it right back on that 6, because that was the base. Now, since we do know our squares, I am going to have you, anytime it has a squared, I want you to apply it. So we're actually going to go 1 to the 36th power, because we know what 6 squared is. All right, 6 times 6. All right, so here is our product of powers, where we're going to apply it to everything inside. So I'm going to go 5 to the 3rd times 6 to the 3rd. We have to apply it to everything on the inside. Okay, product, and then of a power, so we're going to raise it to that power. All right, this is a negative exponent. It's similar, but it's already in a fraction for us. So when it's already in a fraction, again, remember this just says take the reciprocal. So we're going to flip this over. There's my negative. I'm going to reapply. But we're going to actually apply this like the last one we just did. I'm going to have you guys apply this exponent to everything on the inside as well. So we're going to get 3 to the 3rd over 2 to the 3rd. We're kind of combining a couple together. All right, so now we're actually back to our first one, product of powers. So we have b to the 4th times b to the 7th times b. And this one is just b to the 1st. So anytime you just see one of them, this is actually an example from our page we did. Remember that 3 was to just hanging out by itself. So it's also just a 1. Same works for these. So we are going to just add. We're going to go b to the 4th plus 7 plus 1. So 7, 8, 9, 10, 11, 12. And we get b to the 12th. All right, so these examples get a little trickier because we have to kind of sometimes apply multiple rules at once. So these rules only, product of powers, quotient of powers, and power of powers only work if they have the same base, right? I couldn't do those things if they didn't have matching bases. So for this first one, this is a quotient, but the only ones that have the same base are my a's. So those are the only ones I'm going to apply my rule to. So I'm going to leave the 9 alone, and I'm going to times it by a to the 13th minus 3, because that's my quotient of powers rule. Subtracting those exponents. So once I subtract them, I get 9a to the 10th, and then we're done. I can't multiply a with 9, right? I can't take that. I'm not raising 9 to the 10th power. Only the a is being raised to the 10th power. All right, so here's another one that's similar quotient, but the only difference is now we have a number in the numerator as well as the denominator. So we're going to combine these as though it is a fraction like this. We're going to then multiply it by this one together. So that's k to the 7th minus 5. And then because we have nothing with the x, we're just going to put the x back. The numbers can go together, and then the same bases can go together. Excuse me. But what's really nice is we can reduce 15 over 3. That's 5. And because they're opposite signs, it's negative 5. Then we have k to the 2nd, because 7 take away 5 is 2. And then we have nothing with x, so we just leave it, x to the 3rd. So when you're doing these, just do one piece at a time and then bring them all back together, because they don't have the same base, so you can't do anything until you're done with all of them. Okay, so this one's similar to the second one, except instead of quotient, we're multiplying. So commutative property of multiplication allows me to move things around so that like things are together. This is technically 6 times k x to the 2nd, not k, x to the 2nd, times negative 3 times x to the 5th. Because everything's being multiplied together, I can multiply them in any order I want to. So what I'm going to do is I'm going to put my numbers together, and then I'm going to put my variables together. So now we have negative 18 times x to the second plus 5, because remember they're being product to powers, so they're being multiplied together. And so we get negative 18 x to the 7th. Okay, commutative property allows me to do that. So knowing your rules is really important. All right, the main thing to remember this is that you need to memorize the rules. I absolutely have to memorize them, because if you're trying to look them up every time, they're going to be very difficult, okay? So here is your independent practice. Remember, to get full credit on your note takers as a homework assignment, you have to have the independent practice done. At least try. Something needs to be applied, something needs to be there. You cannot leave it blank. Okay, until next time.